Welcome to RoboLoop, an innovative electronics recycler located in State College right here in Pennsylvania. What we're going to do today is we're going to go through this facility and understand why what they do is so important. Because what they do is they tackle the massive e-waste problem from flat panel TVs to appliances, and they recover valuable materials like metals and plastics. We'll explore why operations like this are crucial for a circular economy, where waste is actually turned into resources, thus reducing our reliance on fossil fuels and promoting sustainability. Greetings, world, live from RoboLoop. What is RoboLoop?
Back in 2008, we started a business called eLoop. So we've had this facility since 2013. Started to pay attention to the fact that flat panel TVs were the fastest growing part of the waste stream. When you look at any of these flat panels, you see black. So when you look at black and you look at all the different screen sets that are in there, there are several layers of plastic.
RoboLoop exists because electronics like TVs contain plastics, for example, polycarbonate, polystyrene, ABS, and these would end up in landfills if they were not recycled. By disassembling them, they recover these plastics, turning what would be waste into raw materials for companies like Covestro to reprocess into new products.
What we're trying to do is look at this as a second product, and that is when we separate this, you can pull the sheets apart, and inside of there we can scrape all the paste out of it, where we're able to use a biogenic formula to basically recover indium and gallium.
What we're talking about here, folks, is not just about plastics recycling. It's about reducing waste. The key to the circular economy is closing the loop, and this is what RoboLoop is doing. Because what they're doing is they're recovering the materials from these housings and turning them into high-quality recycled plastics. What they're doing is also they're bypassing the need for new fossil fuel-based plastics, and of course, they're cutting emissions. Now, depending on which region of the world you're located in, the rate of e-waste recycling today is less than 40%. In some regions, it's a lot less, by the way. And what RoboLoop is trying to do is they're trying to raise this number.
When we started this business in 2008, and we would hold a collection event, like with the ones we hold in Allegheny County, 80% of the weight would come from CRT televisions. Right. Okay, so years and years later, we're in a situation where now the amount of weight is around 40%. So the introduction of all the flat panels, smaller IT equipment, etc., has led to those collection events not requiring 4 tractor trailers to be there. Now we might have 2.
Or 1.
And we'll still service 700 and some cars.
Yeah.
Right? You've got all kinds of wiring. So we recover the wire. Those materials like routers, networking switches, things of that nature, we have a downstream that will end up shredding it and recovering the materials.
You can recover materials from the cables?
Absolutely. If you look at those cables, they all have different ends on them.
Right.
So depending on whether it's Cat5 or a plug wire that you would have on an appliance, we sort all that material because it pays differently at the scrapyard.
What companies like RoboLoop are doing is they're actually driving circular economy forward by innovation. They're actually using robots to overcome design challenges. And what they're doing is they're ensuring that materials like plastics are reused, not wasted.
And this is the PL2, which stands for the Punchline 2. So it was the second machine that we actually built. The first machine is right behind me. There's actually 3 separate cameras. You're looking at one of the camera views here. This is in real time. He can select the locations where he sees fasteners on the back of the television.
Right.
So where we want to be at full production level is all of this is going to be automated.
Right.
So there's computer vision running on the cameras that are going to go through, automatically locate where the screws are. And basically, instead of having Andrew, the system will figure out for itself. And you can actually see, so the green path that you can see.
That's the path that it's going to follow.
Yeah, so it's actually solving what is the shortest path to go and actually punch. Then he hits go.
Going.
And you'll see the robot is now basically autonomous.
I love it.
So it's figuring out for itself where to go, but it's tracing out this path, and then he's getting the feedback when it's actually hit the locations. At full autonomy, even if like the television moves a little bit and we miss a screw, we want the system to be smart enough that it will be able to figure out to go back to that location and repunch it. So we really are moving towards a set it and forget it, not having to have a human here in the loop. The pneumatic system itself looks pretty simple, but to actually get it tuned and to work 100% of the time on 100% of what you're going to see is where the actual, the magic sort of comes in.
This hands-on experience with dismantling all sorts of appliances with different design factors and form factors is giving a cue to designers in all industries that they have to be thinking about disassembly when they're beginning the design life cycle. In other words, they have to be thinking about circular design. One of the things that we're talking about, and we have been talking about this for a few years, is the OEMs have to make their devices easier to take apart, easier to repair, easier to upgrade even. And that puts the entire idea, the concept of planned obsolescence on its ear, because now you're not planning to make it obsolete, you're planning to make it functional for a long time, and you're thinking about what happens at end of life. At end of life, it needs to be able to be pulled apart easily by folks like yourself so that the high value components can be segregated and reused. Any parting thoughts as far as what an OEM could do to make your life easier?
Well, there's probably many things they could do to make it easier to take apart, liberate all the materials. But what you run into as a recycler is we're dealing with yesterday's products. Right. And those products may go back a decade. So when you look at it from a recycling standpoint, we've got to come up with ways to take care of it now. We can't wait for the OEM to make all the design changes. We will welcome them. We'll be ready when they come. But right now, the problem is on us. Yep. An example, you end up with an Intel switch. This would be maybe something your cable company gave you to be able to connect to the internet. Well, they wear out, or they get faster ones become available. Right. They become obsolete. They could potentially have a reuse, but if there's no market to buy it, then it ends up being scrapped. Mm-hmm. Okay, you got everything from a DVD player and things like that are coming back. And that's what I mean about the legacy. Right. When you look at changing the way design is, it's going to be a long time before it shows up in my box.
RoboLoop shows why certified electronics recyclers are essential. They recover plastics, metals, and even rare earth elements from e-waste. So what they're doing is they're making recycled materials more widely available, and they're advancing a true circular economy. Without them, waste would continue to pile up in landfills. If you're inspired, please recycle your old devices responsibly, look for recycled content, and look for recyclability in your new devices. Companies like RoboLoop prove that this can be done.